right, so this will be part 2 of the review of the AP curriculum. All right. Okay, so here's the topics for today. There's actually 25 topics, so it should be about 2.4 minutes per topic. It comes from Unit 2, using objects, Unit 5, writing classes, and Unit 9, inheritance. These units go nicely together for me because they're about classes and objects in all 3 units. Why the AP put Unit 2, using objects, as the second unit? I don't know. I don't know why they did that. But if you think about it, this is content from certainly beginning in the 30S course, in the classes unit, and then obviously expanding on that in the 40S course, in the advanced classes course. Okay, so let's start with this first one. Objects, instances of classes. Okay, so it says explain the relationship between a class and an object. So a class is used to create an object. Okay, the class is like a blueprint. It's like a cookie cutter. These are analogies that I've used in this course. This pen is not working very well. To create a house, to build a cookie, you use one cookie cutter to make lots of cookies. You use a class to create an object. Objects can also be called instances. An instance of an object, okay? You can even call it a variable of that type, although I think that word doesn't really fit it as well. Variable we tend to use with like primitive data types like integers, but it still works. An instance of that object, of the class. So when you create it, when you declare it, when you instantiate it, these are words that could come up. So we got to watch our vocabulary here, again, especially because the AP sometimes uses different types of vocabulary. The object is a specific instance, there you can see that word, of a class with defined attributes. So now as well, you can see here the word attributes and behaviors being used in the AP curriculum. I generally use the word properties of a class, and methods of a class. But it essentially means the same thing. Behaviors, actions, functions, properties, attributes, even variables could be used, okay? Sometimes the word fields is used, okay? The class is the formal implementation or the blueprint, okay? The attributes and behaviors of an object. All right, moving on to number 2, topic 2. Creating and storing objects, or instantiation. So here again, you're seeing that vocabulary being used. Now you see 13 subpoints here, so it seems like there's a lot there, but really it's just the AP being very formal in the way they've defined all the writing here, okay? So for example, it uses the word signature. I've used that word before as well in class. You can use the word signature as it relates to a class, and even the word signature as it relates to a method. The signature is just the very first line of code. When you define something, right? So when you write a class and you say like class person, that's the signature line of the class. When you write a method, public, void, attack, that's the signature line of the method, right? So identify using its signature the correct constructor being called. So here you see the word constructor and the word signature. Now you obviously, it does go into it in more detail in another curriculum point. We have a little background as to what a constructor method is. Okay, a signature consists of the constructor name and its parameter list. Now again, this is why I find the way the AP structured this very strange. They're introducing these concepts of methods like parameters before they've taught methods, right? Now you guys are looking back on this, you know what a method is, you know what a constructor is, but it's just sort of defined in this point here. The parameter list. So a parameter list just means obviously more than one parameter. is in the header of the constructor. Here they changed the vocabulary. Signature could also be called the header, right? So, I don't know, I think it's a little confusing when they put it that way. They're basically saying when you write a constructor, you list the values of the parameters, you list their names, and these are sometimes referred to as formal parameters. They're not. No one uses that term except the AP. But who knows, right? If they actually bring up the term formal parameters, that means the parameters inside the method, okay? So when you write a method and you include parameters, those are the formal parameters. The way I taught you, I think, is more correct. When you write a method, those are the parameters. When you call a method, I'm calling a method, this thing right here is generally called the argument. But the AP doesn't say it that way. Okay, it says a parameter is a value that is passed into a constructor. I disagree with that. That should say an argument is the value passed into a constructor. The parameter is what you write into the constructor. But again, those words are often interchanged by computer scientists, right? Like parameter is generally the word used more. But I don't know, okay? And it says these are referred to as the actual parameters. So the formal parameters and the actual parameters, I don't know of much other than the AP that uses that terminology, but you know, might as well be aware of it, right? Constructor said to be overloaded. So now it's even introducing the term overload here. An overloaded constructor, if there are multiple constructors with the same name but different signature, the way I always told you guys what overload means is same name of method, different parameter list. That's what overloading means to me, okay? But they're not wrong when they say that, different signature. Okay, the actual parameters passed to a constructor must be compatible with the types identified in the formal parameter list. That just means if you write a constructor that has like an integer and a string, you have to call the constructor with an integer and a string, so they match the parameter list. That's a really formal way of writing a very simple sentence. This is what I mean by, although there's a lot of things here, it's essentially just very formal writing of content you should already know. Parameters are usually called by value. Now again, for you guys as someone who's learned Java, I can see here where the AP writers of the AP curriculum are coming from languages like C and C++, where you have what are called reference parameters and value parameters. Java has no such thing. So when they say they're called by value, all that means is when you call a method, what you're sending as an argument is a copy of that value. Okay? Let me make that a little more clear. Even though this isn't really about methods, it'll probably come up later and I'll just kind of skip over it. So for example, let's say you have this method over here. Foo. And it takes x as a parameter. And then somewhere in the method it goes x equals x plus 5. That's what the method does. And then over here, you have a variable x, or let's say y, equals 5. You go foo, y, and then you output y. It's not working well today. Okay, so something like that. Okay? So you're passing it this y variable over here, becomes the x variable, adds 5 to it, and then it's done the method. Is it 10 when it outputs it here? No, because it sends as this thing a copy of the value. It doesn't send the actual variable. That's called a call by value. It just means it's sending the value, not the actual variable. That's what's called a call by reference, and technically Java doesn't have reference parameters. Okay, so it's just a weird way of putting it because you wouldn't have learned it any other way. You wouldn't have assumed it any other way, okay? When creating objects, calling constructors without parameters, create objects, constructors with parameters. I gotta speed up to meet our timeline here. Every object is creating using the keyword new, followed by a call to one of the class constructors. I think you knew that. A class contains constructors that are invoked to create objects. Yes, I do that too. Class creates object through the constructor. Same name as the class, right? That's what a constructor does. Constructor has the same name, method name as the class name. Existing classes in class libraries can be utilized as appropriate to create objects. This is just saying you can create objects from classes that you didn't write. Parameters allow values to be passed to the constructor. We do that. You can pass if the constructor has parameters, you can pass arguments to those parameters. Define variables of correct types to represent reference data. Again, I'm not sure why that point is here in this particular thing, and the keyword null. So that one, the only one I would say about the keyword null is if you just create an object, like say you have a class, class person, and then you put a bunch of code there, and then later when you want to create an object, you go person P, but you don't call the constructor, okay? What it's saying there is this value P is associated with null. It doesn't have an object associated with it until you call the person constructor, okay? So that's all that means, right? That null is a memory location that is used to just reference this thing until it's constructed into an object, okay? All right, let's move on to topic 3, calling a void method. So I'm going to go quickly through all these subpoints because this is really basic stuff. This is about methods, okay? So without even going into the curriculum points, we know that methods, the unit you studied in the 30th course, methods are actions. They can be defined as behaviors. This is something you'd see more when you're talking about methods within a class. They're the behavior of the class, right? They are actions, they are behaviors, they are functions. You can even call them procedures. This is just a formal way of describing what a method is. You know that methods can have an input or inputs that we call parameters. Methods could have an output, or they could be a void method with no output, okay? This is what it returns. You've been using methods for a while, so none of that should look unfamiliar to you. This is what methods do. So then, the only thing that might throw you off is it talks about non-static methods. Now don't worry too much about that. Static comes up in the AP curriculum in a minute, so we'll get to that. An object's behavior refers to what the object can do. Procedural abstraction, what a weird term to throw in there, okay? To just say that word without kind of giving it context, all they're saying is, that is kind of what I would call black box programming, which is that you can call a method without having to know what it does on the inside. You need to know what it does, but you don't need to look at the implementation. So procedural abstraction just says that we can use methods in kind of ways that we don't have to necessarily have them completely defined at the time, okay? That's what it says. Allows the programmer to use a method without knowing what the method does, by knowing what it does, even if they don't know how it was written. It's a weird way to put it.
Does like any sort of abstraction come up in the AP course? Or?
No, not at the level I taught it to. There's some terms from our abstraction unit, but nothing of that sort of similar nature. For example, the abstract class is not part of the AP curriculum. Okay. Method signature we already talked about. It consists of the method name and a parameter list. Method or constructor, right, calls the execution of statements. Will execute the statements of. It's just saying it runs through the method. This point here. Before it goes back to after it gets called. I think, again, this is simple stuff you guys know. The dot operator is used with methods within a class. So that you know that, like person.talk. You use the dot operator to access the method within the class. Void methods do not have a return value, obviously. And then the last thing just says, if you use a void method and try to assign it to a value, so something like this, right? Int x equals, say you made a person object called P. P dot whatever the method is. Like this. but the talk method is a void method. Well, then it's not returning an integer. This is going to throw what's called a null pointer exception, right? Because this method returns void, which means that this is going to be assigned a value null, and it can't run with a null value. X can't be null. That's an error that would get thrown, right? Something like that. There are other ways I could have written that. But it's basically saying if you have a void method, don't expect it to return anything to you. All right. Topic 4. We've got to pick up the pace here. Calling a void method with parameters. So really, having talked about a void method, just defining all the parts of a method, this is really about just kind of this whole curriculum point is just about parameters, right? Parameters consist of the method name and an ordered list of parameter types, right? So if you have a void method, whatever that method is called, the name of that method, it's inside those round brackets that you're going to have all your parameters. If any, you could have 0. If you have more than one, you're going to separate them with commas. You guys know that already. The way the parameters are written is they're essentially written like variable types, right? So something like int x. Or it could even be a class level object, right? Like person P. It could be an object. It could be a primitive data type. Each of those are defined as the parameter list, okay? Values provided in the parameter list correspond to the order and type in the method signature, so there you go. Methods are said to be overloaded. So there's an interesting term, overload, again, okay, where it says that you have multiple methods with the same name, okay, so you can have multiple methods with the same name as long as they have different parameter lists, right? Yes?
If they had a different return types, would they
No,
be overloaded?
no, that's a good point. Return type does not affect overloading, okay? So if you had a void method called name and you have an int method called name and they had the same parameter list, it wouldn't allow it, right? It's based on the parameter list, not the return type. Okay. Okay, on to point 5. Calling a non-void method. So obviously a non-void method means it's going to be returning something. Or it's going to have an output to the method. Okay? You might even remember sometimes I would write methods drawn like this, little diagrams of like little machines. And this method could have a output. Now that output could be void, which means it doesn't have an output, or that output could be all kinds of things like an integer or double, or some kind of array, or a class level object like person. It could output a person. That's what it returns, right? So this is what the method returns. This means it is a non-void method. So it's one of the things that returns something. Now it could, as we've already talked about, have an input. Sorry guys, I'm working with this pen the best I can right now. Okay, it could have an input, or it could be essentially a void input. Although you don't put the keyword void, you just leave the brackets empty, okay? And then again, like we just talked about, those are all your parameter or parameters. Okay, non-void methods return a value of the same type as the return type in its signature. So if you define the method as having an int return type, that's what it's going to return, okay? It must be stored in a variable. To use the return value when calling a non-void method, it must be stored. So in other words, when you call the method, you then store the value that's being returned, or you use it as part of an expression, as it says there, right? So that's a weird way of putting it, but I could kind of show you an example of that really simply. Like let's say you're doing a math equation, int x equals 5 plus 3 times, and then you go like math dot some method here. That thing that it returns right there, say it returns an integer, is then used as part of the expression, right? So it's just calculating because it's returning that number right there and factoring it into the expression. That's what that means. All right, on to topic 6. String objects, concatenation, literals, and more. So this is more about strings. I know we had a class where we talked about string methods specifically, but just some terms coming out of the curriculum here, okay? For string class, you can create string objects. Normally, the easiest way to create a string object is just something like this. You put a string literal right here. You just, in other words, put some kind of string value, and that creates a string object S. However, you can use a constructor method here. String has constructor methods, okay? For example, you could say string S equals new string. It does not have a default constructor. So you could make a new string and then pass it a literal. You can make it a string with another string. Like there are ways you can do that. This is not seen that often because this is just so much easier, right, to do it that way. But it does say string objects can be created using string literals. That's what's happening right there. Or by calling the string constructor. That's what's happening right there. Then it mentions how string objects are immutable. This is kind of true, that once you create a string, you can't change it. That's what immutable means, cannot be changed. But it's not like it's a constant. You can, like for example, take a string, S equals S plus, like, and you can add to the string, and the word for adding to strings is mentioned right here, concatenate on a string. So again, watch that word if you see it in the AP exam. Concatenate usually means to join onto a string value. What's weird about this is what it does here when it does this is it essentially creates a new string. And then assigns that new string to S. That's all it means there. But do we ever think that way? It doesn't really matter. We're just changing the string S, the S object, to become a different type of string. But technically they are correct. Strings are immutable, they don't change. So when you concatenate onto a string, you are essentially creating a new string operator, okay? It says that primitive values can be concatenated with strings, so it doesn't have to be a string literal. You could add, for example, an integer. You actually do that all the way back in the 20S course. When you first output something onto a label, you couldn't just directly put an integer into a label. You had to concatenate it with a string so that it would create a string object to place into the label. But, you know, who thinks that way, right? That's just natural flow of the way you write code. The conversion of values to strings. So when you attach an integer with a string, it automatically turns the whole thing into a string. If what you're concatenating with a string is an object, then we know it calls the toString method of that object. Okay. And then it talks about escape sequences. It just sort of slips that in right there. About the /n for a new line, the /quote for a quote, and the // for a slash. It just mentions those three things that you can put those into string literals, and they escape the string literal and create, for example, a new line character, a quote, because you're inside of quotes for a literal, or a slash because you're trying to create another slash object. Okay, on to topic 7. We got to pick up the pace here. String methods. So this is what we review on the review sheet that I gave you guys. It's part of the Blue Book app as well. So you'll have that as a reference, okay? But this is the part of the curriculum that essentially talks about it. So if you're going to use strings, there are available, okay, methods that you can call from strings that could be useful or could be part of a string type of exam question. Okay. Now, before I get into the methods, and I'll just list them, I'm not going to go into detail on them because we've already done that. It does mention in here the term API and libraries. Okay? Essentially, those are the same thing in the context of how important they are. API stands for Application Programming Interface, but essentially, if you can call upon a library of code that you don't have to write, that you can essentially import into your code. Now with strings are part of the Java core library, so you don't have to import them. They're automatically imported. But it might be easier to think of API and libraries for something early that you learned in the course, like JOptionPaint. Okay, so just to take a step to talk about that, just to kind of show you what all that kind of means. The first time you use JOptionPaint, you might remember at the top of your code, an import line was added. And yeah, JOptionPaint was imported. But there was actually something before that. Do you guys remember what it was? Before JOptionPaint, there was a dot right here, and there was a word right here. Do you remember the word? It was swing. And before that, there was a word. It was Java with an X, like javx.swing.joptionpaint. Feel free to look back in old code and you'll see that. The first time you used a color as part of a code, it would have been java.awt.color. First time you used color in that code. Now, interestingly enough, if you look back at this code, you'll notice the J and the C are capital letters, implying they are classes, which they are. But this stuff is not. You can also see that with the word system. Oh my goodness. Let's try and get this somewhat better. Dot out. Dot, for example, print line. Well, we know print line is a method. We know system with the capital S is a class. But why does swing, AWT, Java, JAVX, and out have a lowercase letter, not a capital letter? Well, think about what you guys have written before you try to answer that. What did you write that was always in lowercase only? Packages, that's right. And you'll notice here it says, the string class is part of the java.lang package. Classes in the package are available. So that's what's happening. These APIs are these big pieces, are essentially a library of code separated into packages with classes inside the packages. And so when you want to use JOptionPaint, you're importing this package of code with that class to be able to use. So you're getting specific to that. But that's just what it means by that. So if you see the word packages, you knew what that is. If you see the word API, and if that ever gets confusing, that's kind of why the naming style is the way it is. The lowercase indicates, in this case, a package within an API of a library of code built into that class called JOptionPaint that you're importing into yours, okay? So that's just a little sidestep on what that stuff is essentially meaning. Okay. So then it talks about the string objects, okay, that they are indexed, right? So if you make a string like cat, it's essentially within like an array 0, 1, 2. I'm getting very frustrated with this pen right now. It's really, really starting to get me upset. I'm hoping that this thing is going to start working a lot better. Okay, let's see if I can maybe switch to calligraphy pen style. Okay. All right, so there is a string, okay, built in that way. That's what it's saying. Index values from 0 to length minus 1. So yes, this string has a length of 3, and that's 3 minus 1, the length from 0 to string minus 1, just like arrays. And then it mentions all these methods right here, the quick reference sheet methods. We don't have time to go into all of them, but you can see there the string constructor, the length method, the various versions of the substring method. You will see these show up in exam questions. I'm sure you have seen these show up in exam questions. So kind of good to practice those. The equals method, which we studied in the 40S course as part of the object class. So you've seen that in a lot of context. And the compare to method, which again, you want to kind of examine that compare to method and kind of how that works. All right, so that's strings and objects come together. For point number 8, wrapper classes, integer and double. Okay, so I've mentioned wrapper classes in the 40S course, maybe even a little bit in the 30S course. So maybe just as a little context to this, right? I'm trying to draw something really quickly with a terrible pen as usual. Okay, with a bow on it. Oh my goodness, guys, frustration level, especially being on a Monday here today, is off the charts. Okay, bow. Present. I'm just going to start over again. Okay? When you get a present, okay, something is inside of that present. Okay? That's the way you can think of a wrapper class. It's like wrapping something up in a present. So the primitive data type integer, lowercase I, is a primitive data type. It can be wrapped inside of the class integer, which is its wrapper class. Okay? Double with a lowercase d can be wrapped inside of double with a capital D. This also is true for both Boolean and char for characters. Okay? That's what it's saying there. Then you have wrapper classes for integer objects, which have integer methods, and double objects, which have double methods. Because this is a class now, it has access to methods, whereas this is a primitive data type. And primitive data types do not have methods, right? You can't go int x and then go x dot and expect a method to pop up. It will not. But integer x will allow you to access methods like, for example, the toString method, which it inherits from object. So that's what it's talking about here, that you can use these wrapper classes, okay, to then, and the word is box up a primitive, okay? That's sometimes you can see here called auto boxing, which is just that you could go like integer x equals 5, and it will automatically auto box a primitive integer inside of the integer object. Then I can call things like x dot toString, okay? Then it talks about unboxing, which is this way that Java can automatically turn a wrapper object into a primitive. Let me maybe try to do an example of this.
Eisen and Yevshena to the office, please. Yevhenlia.
Okay.
Thank you.
Okay, come on, pen. You're gonna work now. You're not gonna screw around. Okay, so this is an example of auto boxing, right? So it's automatically taking, well, actually, maybe we'll do it a slightly different way. Oh my gosh. Just one second. Okay, so here's an example. Put the Z right there. Where we have a primitive data type. That primitive data type is then being turned into a wrapper class level data type, X, and that's called auto boxing. So it's automatically turning the primitive into a class level object. Then we go back to a primitive object. So this is a primitive, this is a primitive, this is a class level object. And now it's doing what's called unboxing it. Saying, oh, I have a primitive, I have a class object. Let me unwrap it so it can be a primitive again. That's all that means. Okay, if you see words like unboxing and boxing and auto boxing, it's just talking about the conversion from primitive data type like integer to class level data type called integer, right? And then it talks about the methods within the integer and the double class, which again, we've already kind of studied, where you can call methods to pull out the values, you can use constructors, and then you can use min value and max value, which are actually static objects of the class, but we'll talk more about static in a minute. Okay, let's move on. Using the math class. This is also in your reference sheet. So in your reference sheet, it talks about the math class. Now here again, it's using the keyword static. So let's take a minute to talk about static. The keyword static can be applied to static variables. Oh my goodness. What if I just do this? Could I just drop my finger? This finger going to be this. Okay, that'll work. And static as it applies to methods. Okay, so the word static, as you guys might remember the way I defined it, could be easily just thought of as shared. Now in a minute, there is a curriculum point about this, about static specifically. But here it's saying calling the static methods of the math class. So what that means is I'm going to use the math class without creating a math object. I just use the math class and I call the method of the math class because I don't need to create an object when it's a static method. This is true for classes like J-option pane. You don't say J-option pane J equals new J-option pane. You can just call a method of the J-option pane class. J-option pane dot show me a message dialog. Math dot give me the value of pi, which is a variable. Math dot give me a random value. That's a method you can call from random. So these are what they call static methods. You access them with the dot. You access them directly from the class. Okay? And that's what it's essentially saying here. And then you can use those methods like absolute value. You can use the power method. You can use the random method. You can use the square root method as part of mathematical expressions, as part of your coding. Okay? It does mention in the last point that the random one is one that you got to kind of manipulate a little bit to fall within a range. And you guys saw that all the way back in the 30S course from me. Maybe even if you think about it as part of the 20S course, that random numbers have to be defined to come within a range. There's formulas for doing this, random number formulas, or you can use methods, random type methods in sort of that way. As long as you understand that they're going to be in a defined range, you can kind of manipulate it the way you want. Okay, let's move on. Topic 10. Is this still going to work? Yep. Okay. All right, so here's a word you rarely see, but except for the AP curriculum, designate. Okay? As a matter of fact, I, just as a subpoint, looked up in several coding textbooks. Did the word designate come up? No. Designate access. Designate just means to assign something. So when you're assigning a value, you're designating it. Like I designate you as the classroom leader. It means I'm assigning you to be the classroom leader. But this anatomy of a class section is about public versus private in the concept of encapsulation. So this was something we covered in the 30S course and went into detail on the 40S course, how things can be public, okay, how things can be private as it relates to a class, okay? So as it relates to a class and a class object, if it's private, it is only internal to the class. So a public property, a public variable, a private property or private variable means that variable can only be accessed within the class, whereas a public variable or a public property can be accessed within the class and outside the class, okay? This also applies to methods. So for example, a public method could be called outside the class, whereas a private method can only be called within the class. This should be well known to you. Now, in the 40S course, I taught you an in-between level of encapsulation, the idea of protected. I do not believe, I could be wrong, that protected is part of the AP curriculum, so you don't have to worry about protected. It's not part of their curriculum content. It does mention private, it does mention public. Classes are designated public. The keyword private restricts to the class. If it says that, the keyword public allows access from outside the class. Access to attributes should be kept internal to the class. So it's basically saying you should try to keep your variables as private. Constructors are public. I think that's pretty obvious. Why would you have a private constructor? It doesn't even make sense. Access to behaviors can be internal or external. So here they're switching the vocabulary. So public, they like to use the word external to the class, and private, internal. It's just another way of thinking of it, right? This is an internal private property, an internal private method, an external or public method. This also, under encapsulation, sometimes they'll use the word visibility, because it implies that you can see something outside the class, or it is hidden, sometimes they'll use that word, inside the class, okay? So you can't see it because you're not inside the class. Data encapsulation is a technique in which implementation details are kept hidden from the user, right? So you see that term there. When designing a class, programmers make decisions as to what's public and what's private to essentially make the class as functional as possible. Data can either be accessible or modifiable. It can be both or neither. So that's leading into what's coming up next, as you guys know, about accessors and mutators. Do I want this data to be just seen outside the class, or do I want it to be seen and be able to be changed outside the class? And then, yeah, that's essentially just lots more terms all around that same topic. All right, let's get going, because we're almost at the halfway point. We're well past the halfway point in the timeline here. Constructors. So we've already talked about that, what a constructor method is. So a constructor is a method. It may have parameter or parameters, maybe, doesn't have to. If it has no parameters, it is defined as a default parameter. Okay, so a constructor with no parameters is a default constructor. Parameters have the same name as the class. Parameters have no return type, including the word void. No void. If it's a constructor, that's how it's defined. Same name as the class, no return type, including the word void. Can have parameters, cannot have parameters. It can be overloaded if you want, so you can have multiple parameter options. Okay, what does the constructor do? The constructor usually sets the values. And by values, I mean the properties, to some kind of default value. These are all the things I've taught you in the 30 and the 40th course about constructors. And you can see this is the way the AP defines it. Instance variables, that means properties. For the attributes, that means properties, are initialized, which means they're set to a starting value, through the constructor, right? Object state refers to its attributes and values at a given time. So what's the state of the object? And is defined by those variables belonging to the object. This creates a HAZA relationship. So if your class contains a relationship to another class through its properties, that's a HAZA relationship, okay? Or usage relationship. Constructors are used to set the initial state of an object. That's what I said right here. which should include the initial values or the default values, which I said right here. Okay, constructor's parameters are variables, and the constructor provides data to initialize those variables. This is again just really complex language for a very simple concept. When a mutable object is a constructor parameter, the instance variable should be initialized with a copy of the referenced object. This is what I said to you before. When you call a method, you're sending it a copy, you're not sending it the actual object. In this way, the instance variable is not an alias of the original object, which means the word alias we covered in the first review video means two names of the same memory location. So basically, it's just saying when you call a constructor, it's passing copies, okay? When no constructor is written, Java provides a no argument constructor. The no argument constructor is the default. This is why you can create a class without any constructors, and it will automatically create a default constructor for you. In that default constructor, it just sets all the values to default. That's what it does. Okay, topic 12. Describe the functionality and use of program code through comments. So this is a curriculum point about comments. So let's see, what have I taught you guys about comments? Comments are useful. They are part of a professional sort of way of creating code. This is also a very good academic way of documenting your code, okay? So if you're in a profession like software development, comments would be part of that profession. When you're studying computer science in an academic world, just like when you're writing essays in an academic world, a certain style of documentation is required, just like essay styles like APA. Comments have a professional or an academic. They are useful, they're not useless. They can actually be part of problem solving. They can be a technique for helping you to solve problems. When you apply comments to specific things, like for example, specific ways of commenting methods, specific ways of commenting classes, right? Or even perhaps data structures, okay? Then there's even more sort of commenting things you should kind of be aware of, and that those could fall under a specific type or style of commenting. For example, a common style used with Java is the Java doc style of commenting. But that's just one style, okay? It is a common style for using Java, but there's some kind of professionalism and academic sort of slant on this. So looking at what it wrote here, describe the functionality and use of code through comments. So there's a use to it. They're ignored by the compiler, so that makes sense. Comments aren't part of code. They're just used for programmers. They include the /star method, the // method. The /star must be closed with a */, okay? And then finally, as it even mentions there, the style where it uses a slash and 2 stars, that style of commenting connects to a specific style, right? So it's going to be often incorporated by the IDE to help you with that. That's why you can use a NetBeans and put /**. It'll help auto-comment things like methods and classes and stuff, okay? And you can see there, Java.doc comments are used to create API documentation. So eventually, if your little program becomes something bigger, that style of commenting gets incorporated into the program itself. And then it talks about preconditions and postconditions. Believe it or not, I actually covered that with you guys in the methods unit, that traditional commenting styles, precondition, postcondition, are very science-like, you know, like the pre before you do a lab and the post after you do a lab to kind of see the results of your experiment. That really just means preconditions are the inputs or the parameters, postconditions are the outputs or the return type as it relates to methods, okay? Okay, topic 13, accessor methods, okay? So the accessor methods, to access something means you are getting something, okay? So a method that gets something is an accessor method. So because it's a method, it will be returning something to you. Okay, what's it getting? Usually the getting or the accessor methods are part of a class. Usually, not always, the getting or the accessor methods are getting something private from a class. okay? This creates it so that it could be essentially defined as a read-only property. So if I just get something, I'm not changing it, I'm just looking at it. I could get a value without changing the value. It will return that value from the class that was a private value, and I could read it without changing it. Sometimes when you say things are not changeable, it will use the word immutable. Remember that word in a second. Immutable means it cannot be changed. Okay? So I'm just getting it, I'm not changing it. Void methods, non-void methods, return by value. It's just talking about returning keyword, the return keyword. The toString method it mentions here, that's a good example of a accessor method. It doesn't start with the word get, but toString is getting the string value and returning it to you, okay? System.out.print or print line, if it passes an object, it automatically calls the toString method. We learned that in the 4ES course, that we don't have to call toString when we place it inside a system.out, because toString gets called automatically. All right, that's accessor. The next one, mutator methods. Mutator means changing. Okay? Setting, changing means I'm mutating. Changing it. Okay? A set method usually, doesn't always, has a parameter or parameters, okay, that say I'm going to change. Set methods, like get methods, like accessor methods, are part of a class. They're often, not always, affecting private encapsulated data. So I'm setting that private data, I'm changing it, okay? I'm mutating it, okay? So now we're talking about mutable data. Mutable, the opposite of immutable, means it can be changed. So a set method is written so you can change that data. And then it mentions, I can't remember if it mentions in this description or the other one, you can have both setters and getters, accessors and mutators, or you can have one of them. So for example, you could have just a get method, just an accessor method, without a set method, which makes then an internal property immutable. You can access it, but you can't change it. Or you could have a set method, so you could change it, okay? Yes?
My voice, so I'm
That's
so sorry.
okay.
Could you write what a mutator looks like? Like just a quick.
Sure. Okay. Okay, so let's say we had a class, person, we had a private, int, age. So that is an encapsulated property outside the class. So let's say later on, we make person P, and we try to go P.age. No, can't do that. That is a private property. But then we write a method. Void set int a, age equals a. We write a accessor method. Int get, no parameters, return a. That's our class, okay? So because we can't write this line of code, we could go like int a equals p.get, and it would get the age, return it as an integer, and now we have access to the integer. We can't change it yet. But then if we write this set method, we could go p.set 5, and now it sets the age to 5. It changes the age. So we can have accessors and or mutators in that context.
Would any student who was just down here
Okay.
for student of the month with the green folder, please come back to the office. The picture did not work, but any student who just received a green folder for student of the month, please come back to the office right away.
All right, we got to speed up here in the home stretch here. Now again, like I just quickly mentioned, if we run out of time by the end of the period, I will finish up this video at the end of the day today and then post it on YouTube as well. But let's just kind of keep going. Writing methods, okay? This is again more of the same type of information about methods that can access private data, okay? Non-void methods with parameters. Good programming practice, not to modify mutable objects. When an actual parameter is a primitive value, the formal parameter is initialized with a copy. So it's restating a lot of the same things we've talked about, just in more formal terms. When an actual parameter is referenced to an object, okay? If it's a reference to a mutable object, passing a reference parameter. There is no reference parameters in Java, so that's a weird way of putting it, okay? So it's basically talking about using methods, calling methods, and using them with your inputs, your parameters, and using them with your output, your return type. What are different ways I can use methods when I create them so that they can be useful to me? Do I write a method that returns something, or do I make it a void method? Do I pass it a parameter or parameters? Or do I leave it as just empty brackets? It's basically saying when you write a method to make it a useful method, you should consider the construction or the software development of that method in its context. Okay, moving on. Static variables and methods. So here's where the word static again comes up. And it's talking about variables and methods like I did. So just to refresh your memory, static essentially means shared. As I said, it refers to both variables and methods, static variables, static methods. Okay, so because they're shared, here's a common way to put it. So this means you can access, or you can call, in the terms of reference methods, from the class itself and not necessarily the object. Okay, so I will complete this video. Other than that, I will see you guys tomorrow. Have a good day. Okay, so let's finish up here with this static methods and static variables and static properties. Let me just get this all set up again for you guys. Okay, so let's maybe use it more like in an example. So a better example is in the math API. When you say math.random, you are calling right here a static method. When you say math.py, you are accessing a random property. That property happens to be a constant, but it is in fact a static property. You're calling it from the class, not from an object of that class. You don't have to go math m equals new math and then go m.py. That is not necessary. Instead, you can call it directly from the class itself. So that's what that means. All right, on to topic 17 now. Okay, so for topic 17, we're talking about the word scope and access. Scope and access means where these properties or where these variables can be accessed from, or even sometimes it can be described as where they are alive, right? So simple position of scope that you'd learn in the 20th course is global scope, or a global variable, and local scope, or a local variable. Local variables, which you could understand at the 30th level, would be variables that are declared inside of a method. So they are local to the method itself. Whereas global variables are part of the entire class. The entire class of code has access to those variables. That's what it says when it says explain where the variables can be used. That means where they're being accessed. Local variables can be declared inside the body of constructors and methods. Constructors and methods is a weird sentence because a constructor is a method. These variables may only be used within the constructor method. So when they're local, okay, they are declared inside the method, they are used inside the method, and they essentially die inside the method. which means they no longer hold their value after the method has finished its execution. Whereas class level variables exist as long as the class itself exists, or an instance of the class, okay? And then we have, where there is no local variable, an instance variable. That's also why local variables are sometimes called instance variables, because they're only available for the instance of that method, or for the instant that method exists, okay? Formal parameters and variables declared in a method or constructor can only be used, so that's essentially saying that these are local, through method decomposition. A programmer breaks down a problem into smaller subprograms. A weird place to put that, but I guess it's part of scope in general, that methods allow you to problem solve, like we talked about before, and turn bigger problems into smaller problems. All right, point 18, the keyword this. This I often describe as a placeholder inside a class. It's a placeholder keyword. It's used inside class code. And what is it a placeholder for? For an object later instantiated. So an object that will later be created will have a name, right? So when you're writing class person, you put your code in here, and then later on in your code, when you use class person, and you go person P, now the person object has a name, P. But at the time when you're writing the code, you use the keyword this as a placeholder for that. And the AP describes it this way. Evaluate object reference expressions that use the keyword this. So this would refer to this class itself. Within a non-static method or constructor, the keyword this is a reference to the current object. So that's what I was just saying, for the object that will eventually be created. The keyword this can be used to pass the current object as an actual parameter in a method call. So if you use the word this as an argument, it means this object is being passed. All right, on to topic 19, superclasses and subclasses. So now we're talking about inheritance. One of the key features of object-oriented programming, inheritance. So create an inheritance relationship. That's the is relationship. And with that comes words like the superclass. And the superclass extends to the subclass. Subclass can also be called the child class. And the superclass can be called the parent class. The subclass can also be called the superclass, subclass. The superclass can also be called the base class, depending on the programming language. And again, just be comfortable with the AP vocabulary. A class hierarchy, so that's the build, like which is above the other, putting common attributes and behaviors. So we are inheriting all the attributes that are public. All the methods that are public are being inherited by the subclass from the superclass, okay? Classes that extend a superclass are called subclasses and draw on existing attributes and behaviors. Extending a subclass from a superclass is the is-a relationship from the subclass to the superclass, and in code, to use this in Java, it uses the keyword extends. That's the keyword that it uses to initialize inheritance in Java. All right, on to topic 20. Writing constructors for subclasses. So we're back to constructors in this. So create an inheritance relationship from a subclass to the superclass. Constructors are not inherited. So that might be an interesting point, just that constructors are not something that gets inherited, but they can be called by the subclass. So let's put this in more of a coding example. Class person. So I had that class, and then I made the person constructor. Public person, whatever code you want to put there. And then I have class student, extends person. So we have inheritance going on. And then here I have a student constructor, student. And in that code, I make a call to the super constructor. So the student constructor can call its parent constructor. Okay, superclass constructors can be called from the first line of the subclass constructor by using the keyword super and passing any appropriate. So if I had a parameter here, then I have to pass it as an argument here. If that is a parameter here, and then later when I create student S as a new student, the argument I put here would get passed through here and then passed over to the superclass right here, right? Depending on how you use that. When a subclasses constructor does not explicitly call a superclasses constructor, Java inserts one. So if I didn't write this, Java would make the call to construct a person when it constructs a student. Regardless of whether the superclass constructor is called implicitly or explicitly, that means did you write the code? Okay, that's explicit, or did you not write the code and Java did it for you? That's implicit. The process of calling a superclass constructor continues until the object superconstructor is called a superconstructor. At this point, all of the constructors in the hierarchy execute beginning with the object constructor. So this is an example from our 40S course of where the object class comes into play, just as a reminder of that. All right, on to topic 21. Overriding. We've already been talking about this, but let's continue a little bit about overriding. The idea of override, a method override, okay, is a little obviously different than a method overload. Overloading is two methods with the same name, but different parameter lists. Okay, or they have different method headers. So they may have the same name, but the header itself has a difference in the parameter list. Overriding methods deals with classes that use inheritance. So you have override when you have inheritance. Override does not take place with a regular class unless it's inherited. All right, so it's create an inheritance relationship from subclass to superclass, okay? Method override occurs when a public method in the subclass has the same method signature as a public method in the superclass. So if we had two classes, class person and class student, okay, they both had a method with the same name, but student, can't write it properly, extends person. If a student extends a person, then this method here would be overriding this method by that nature. Any method that is called must be defined within its own class or subclass. Subclass is usually designed to have a modified or overridden method. So that's the point. When you create the subclass, you will want to override those methods to create your own version of those methods. Otherwise, it will definitely inherit all the public methods, and they will be used as if they were part of the other class. All right, on to topic 21. The super keyword. So like the keyword this, the keyword super is used within the code of a class. But now what it is, the keyword super is a reference to a superclass or a parent class. Okay, so whenever you use the keyword super, you're referring to the superclass of itself. So if we have class student extends person, and then somewhere within the code of student, I use the keyword super, like for example, super dot, or I call and then I have a method name here that I'm calling, or super dot, and I'm changing a property of the superclass, or even just the keyword super with two round brackets, and I'm calling the super constructor, a constructor from person. I'm accessing a property of person. I'm calling a method of person. I'm calling anything from the superclass that is publicly available to me through the keyword super, okay? So it can be used to call, as you can see, constructors and methods. So you can see there's a constructor, there's a method, okay? It can be called in a subclass using the keyword super and the method name and any parameters that are appropriate. On to point 23, inheritance, creating references using inheritance hierarchies. So now we could be having multiple levels of inheritance. So classes connected to other classes, connected to other classes through some type of inheritance relationship, right? So this one is, right? And since this one is inheriting from this one, and that one's, so this one is kind of inheriting from this one. I don't want to draw any weird lines there to confuse you, okay? But here you can see the way it's defined it. When a class S is a class T, so class S is a T, okay, refers to the superclass, okay, and S is referred to as the subclass. That's just more definitions there. If S is a subclass of T, then assigning an object of type S, so if S is later created into an object, so S equals new S, okay, that S object, okay, facilitates polymorphism, right? So S still is a T. It is an S and it is a T. That's the idea of polymorphism, that it is poly, many, being able to be used in many situations. S is a subclass of T, then a reference of type T can be used to refer to either T or S, right? So if you have a method that takes T as a parameter, you certainly can pass it the object S, because S is a T. This is weird with these letters, but. And then again, you can see here formal method parameters like for arrays or array lists, okay? This is where the subclass and polymorphism can take place. All right, on to the last two, polymorphism as its own topic, okay? So when you have these multiple levels of inheritance taking place, when you then use the objects of one class that has children, you can also use the children of that class through the concept of polymorphism. This also includes the object class. Since object, as a class, is the superclass of all classes, so all classes, whether they're ones you write or not write, all classes in Java come from object. So if you have some kind of method that, for example, takes an object as a parameter, okay, then the argument can be literally anything. Because yes, it can be an object, but it can be any of the child classes or the subclasses of object, which would be anything, okay? At runtime and method, the actual object type is executed for a non-static method call. Determine the correctness of a non-static method call. So again, it depends on what they kind of mean by that. That I'm not sure, I'd have to see an example to know what they mean. All right, and then finally the object superclass. So this was something we learned about in detail in the 40S course. We studied the object class, call object class method. So you might remember some of the methods we looked at was toString, which is also mentioned here in the Java curriculum. We also looked extensively at the equals method of the object class, which again is covered in this. We also looked at the clone method, which is not covered in the AP curriculum, so you don't have to worry about that. So you can see object is part of the java.lang package, the methods and constructors, including the equals method, the toString method, and subclasses often override these, which is literally what we absolutely did in that 40S course. We overrid that method extensively. And that, kids, is the end of part 2 of this review.